In selective precipitation, we use the different solubilities of ions to separate them. Say we want to separate the silver ion and the copper 2 ion in a solution that contains both. First, let's add plenty of HCl. And when we say plenty, we mean excess. In other words, we want that to be the excess reactant, and we want the silver ion and the copper 2 ions to be the limiting reactants. Now we should know this, that copper 2 chloride is soluble, which means that those copper 2 ions that we're interested in will not precipitate out after we've added this acid. Silver chloride, on the other hand, is insoluble, so all of the silver ion will precipitate out as AgCl. And of course, when we say all of the silver ion, we say that in quotes and we wink as we say it, because not quite all of the silver ion will precipitate out, but the vast majority of it. And sure enough, you can see on the right here that silver chloride does in fact form a precipitate. We're going to separate the insoluble silver chloride from the soluble copper 2 chloride by filtering it out. Now there are two standard ways of filtering something out that we use in, say, a high school chemistry lab. Gravity filtration. You put some filter paper in a long stem funnel and you pour the solution through. It's much quicker to use vacuum filtration. The result is the same, but vacuum filtration occurs much more quickly. And of course, to review, when we're doing this, the solid silver chloride will get caught in our filter paper. The copper 2 chloride will come through and will end up down here in the solution that passes through the filter. This all relates to qualitative analysis. Qualitative analysis determines the presence or absence of a particular ion, as opposed to quantitative analysis, in which we determine how much of an ion is present. Qualitative analysis is much simpler. We're just going to go through the general procedure for how we would do qualitative analysis. There are two steps in qualitative analysis. The first one is that we separate the ions into broad groups by solubility. Then we separate a specific ion from the group and identify it with an ion-specific test. It's almost as if we have a bunch of baseball cards and we separate them first according to team. We put the Yankees over here and the Cubs there and the Red Sox there and the Twins there. And then we pick up the cards that are twins and then we separate them into pitchers and catchers and infielders and outfielders and so on. That's kind of what we're doing with qualitative analysis. Let's kind of show you how this works. And again, I'm not interested in my students knowing the specific details. I'm interested in them knowing the general process. Let's say in the upper right corner here that we have an aqueous solution containing God knows what metal ions. If we add HCl to this solution, there are certain things that will precipitate out if the metal ions are present. In other words, if the silver ion is present, or mercury 1 ion, or the lead 2 ion, if those are present, then the compounds, the chloride compounds of those will precipitate out. And we can filter those and then we can test them specifically if we want. Any other metal ions that are in the solution will stay in there. They are not affected by us adding HCl. Now we have an aqueous solution containing God knows what metal ions, but not much silver ion or mercury 1 ion or lead 2 ion, because that stuff got filtered out. Our next step would be to perhaps bubble in some H2S gas. If we do that, we're going to form precipitates with other metal ions that might be in the solution. If any of these metal ions are in the solution, they're going to precipitate out with the sulfide ion that we've just added in. Again, we can filter out any precipitates and then we can test them for a specific ion. Now we have an aqueous solution with even fewer metal ions. And if we then put in some ammonium sulfide, there will be several other things that precipitate out. We can filter those and we can test them for a specific metal ion. And as you can see, basically what we're doing is we're removing certain ions with each step in the process. Finally, if we add some of this substance, we're going to get some insoluble phosphates, barium phosphate, calcium phosphate, a few other things, and what's left are alkali metal ions, which you might remember form no precipitates in aqueous solution. The order in which you add these different chemicals definitely makes a difference. Someone has figured this out already, that we add HCl first, then some H2S, then some ammonium sulfide, and so on. Then we add this, selectively pulling out several ions each time. Here's a picture. Essentially what we have here on the left is a bunch of metal ions. And if we add in some HCl, some of those metal ions will precipitate out as chlorides. And those are the ones here at the top of this second column. These other ions are not affected. So we add in some H2S. Several more things will precipitate out. You can see that the number of metal ions that we have in the solution is steadily decreasing as we are removing them in these steps. Then we add some more of some certain chemical, and these substances are taken out, and so on. That's the essence of qualitative analysis. It's based on the different solubilities of different metal ions with different anions.